everyone. Welcome to Akshara IIT Foundation. This is Srinivas, your maths faculty. Let us go to today's class. Okay. So coming to today's class, so from last three classes onwards, we are discussing about the transformation of quadratic equations, right? Yeah. Alpha, beta roots, then alpha plus 1, beta plus 1 are roots of which type of quadratic equation? X into alpha or x into beta or alpha into k, beta into k, like that. Which type of equations are we are discussing that type of transformations in our previous classes, am I right? I think we did some problems in exercise also. Let us go to the next problem. So just revise the transformation equations and all. Let us go to this problem. See, if alpha, beta are roots of the quadratic equation. Yeah, alpha, beta are roots of the quadratic equation x square minus x plus 2 equals to 0. This is the given quadratic equation, and alpha square beta plus alpha beta square is, we need to identify that. Before that, let us take the given quadratic equation. This type of problem we have already discussed in our previous classes. Let us see one more time. So if you have the given quadratic equation, you know already how to find sum of roots and product of roots. What is the sum of roots formula? Alpha plus beta. Sum of roots is minus b by a. So minus b value is minus 1. A value is also 1. So minus b by a value is 1. Product of roots alpha into beta is c by a. C is nothing but constant term. So what is the constant term here? 2. And x square coefficient 1. So 2 by 1 is nothing but 2. So sum of roots, product of roots. Now what to find? Alpha square beta plus alpha beta square. Alpha square beta plus alpha beta square value. Here, while you are observing clearly, both are product only. That means alpha into beta, here also alpha into beta. But alpha is presenting 2 times, alpha into alpha, alpha square. Beta into beta, beta square. From these 2 terms, I can see clearly alpha into beta. So let us take the common term alpha into beta. From the first term, what is the remaining term here? Because alpha square beta is nothing but alpha into beta. Same way, alpha beta square means alpha into beta square means beta into beta. From first term, if you take alpha beta as common term, what is the remaining here? Alpha. Now plus symbol. From second term also, if you take alpha beta common terms, what is the remaining part? Beta. Now, this alpha square beta plus alpha beta square, I can write in the form of alpha beta into alpha plus beta. Now, I know the value of alpha into beta, that is 2. Bracket indicates multiplication, and alpha plus beta value 1. That means 2 ones are 2. The given required value is our option 4. Okay, no? So just I have taken the given quadratic equation and found sum of roots, product of roots, and the sum of roots and product of roots values you need to substitute in the given condition. What is the condition? Alpha square beta plus alpha beta square. Okay? Right. Yeah, please note it now. Meanwhile, okay. So let us go to the next problem. So this is very easy problem. So let us go to the next problem. X square plus ax plus b, one of the quadratic polynomial. And second one, x square plus cx plus d. These two have a common factor x minus 1. These two polynomials, quadratic polynomials having a common factor is x minus 1. Okay, na? Then we need to find a plus b value minus c minus d value also. So let us write the two quadratic equations or quadratic polynomials, x square plus ax plus b, and the second quadratic polynomial is x square plus cx plus d. Two quadratic polynomials. Okay. Now x minus 1 is a factor. According to the factor theorem, what is the factor theorem? If x minus 1 or x minus a is a factor of a given quadratic polynomial, then f of a equals to 0. That means while you are substituting the a value in the given quadratic polynomial, the entire polynomial value becomes 0, it seems, according to the factor theorem. Okay, na? Same way, here what is the factor? X minus 1. Then in the place of a we can identify 1. That means f of 1 equals to 0. F of 1 equals to 0. Clear? That means substitute one value in first and second quadratic polynomials. I am substituting the one value in first quadratic in the first quadratic polynomial. That means 1 square plus a into 1 plus b equals to 0. F of 1 equals to 0. That's why I have written equals to 0. And second one, 1 square plus c into 1 plus d equals to 0. Because x minus 1 is a common factor. That is a factor for both of the polynomials. Okay? Let us see that. 1 square value 1 and a into 1 is a plus b equals to 0. That means the plus 1 you transpose that side, it will be minus 1. So simply you can identify a plus b value minus 1. In same way here, 1 square value 1, c into 1 c plus d equals to 0. Same way, transpose plus 1 towards that side, then we will get c plus d equals to minus 1. Now just observe equation 1 and equation 2, both are get the answers are minus 1. A plus b value is minus 1, c plus d value also minus 1. But actual condition is a plus b minus c minus d. Now we need to find a plus b value minus c minus d value. So a plus b I can write as it is a plus b, but c minus c minus d I can take minus of c plus d. Can I write like this? I am just taking a minus as a common term here. Minus into c, minus into d, minus d, like that. Now a plus b value is minus 1 minus c plus d value also minus 1. Okay. So minus 1 plus 1 is becomes 0. Therefore, the required answer for the condition a plus b minus c minus d is equals to 0, or option 1. Please note it. Right. So let us go to the next problem. Yeah, same like previous one. Here x minus 2 is a common factor. X minus 2 is a common factor of the expressions or a polynomials. X square plus ax plus b, first expression, and the second one is x square plus cx plus d. Check. Here also both equations, x square plus ax plus b, x square plus cx plus d. X minus 1 factor, and next problem is x minus 2. How we did? X minus 1 factor means we need to find f of 1 equals to 0. Same way, here x minus 2 factor, then f of 2 equals to 0. So let us take both the quadratic equations, x square plus ax plus b, and second quadratic equation, x square plus cx plus d. Clear? Right. So according to factor theorem, we need to find f of t equals to f of 2 equals to 0. That means substitute 2 value in first polynomial as well as second one also. So x square, in the place of x square, 2 square plus a into 2 plus b equals to 0. In same way I am substituting here, 2 square plus c into 2 plus d equals to 0. Okay. Now 2 square value how much? 2 into 2, 4. Very good. 2 square value 4 plus 2 into a, 2a plus b equals to 0. Next this one, 4 plus 2c plus d equals to 0. Both are same looking like, because both are common factors. We can equate both of them. I am just equating like 4 plus 2a plus b equals to 4 plus 2c plus d. Because first equation RHS is 0, second equation RHS also 0. If the RHS parts are equal, we can equate LHS parts, right? Same condition. That too, we know that both are common factors. Both are having a same common factor. Right. Both sides 4 cancel. Because plus 4 transposing this side, it will be minus 4. 4 minus 4 becomes 0. What is remaining here? 2a plus b equals to 2c plus d. And we need to find out the value of b minus d by c minus a. Now I am bringing the d value this side. That means here already b plus d transpose this side becomes minus d. That is equals to it is 2c. And 2a transpose that side, it will be minus 2a. Okay. So b minus d equals to, from these two terms, I can identify 2 as a common term, c minus a, 2 into c minus a. Okay. Now c minus a is multiplied by 2. When you transpose again this side, it is dividing. So b minus d by c minus a. The answer is 2. Okay, na? Just I am substituting the 2 value in both the polynomials or both the expressions. Then I simplified, I made them equal. Then I found the condition b minus d by c minus a is equals to 2. Very easy and simple to calculate. Shall we move to next problem? Okay. Yeah. Let us go to the next one. See here, alpha, beta are the roots of the polynomial. Sorry, equation this time. Equals to 0 is given now. Equation x square minus px minus q equals to 0. Then alpha power minus 3 plus beta power minus 3 by alpha cube plus beta cube. Okay. Right. So let me identify sum of roots and product of roots first. The quadratic equation x square minus px minus q equals to 0. The sum of roots alpha plus beta. Formula minus b by a, right? Minus b value is minus p. A value means x square coefficient 1. Now minus or minus become plus. So sum of roots value plus p. Now product of roots alpha into beta. Constant term by x square term. What is constant term here? Minus q. Or x square coefficient 1. So the answer is minus q only. Now let us find this by simplifying. Alpha power minus 3 plus beta power minus 3 by alpha cube plus beta cube. Now you already know that loss of exponent, one of the loss of exponent, that is a power minus n is equal to 1 by a power n. That means whenever you see the exponent is in negative, to make them into positive, we can write it in denominator 1 by a power n. A power minus n is nothing but 1 by a power n. In same way, alpha power minus 3, I am writing into positive way 1 by alpha cube. Beta power minus 3 also 1 by beta cube whole divided by alpha cube plus beta cube. Okay, na? Now let us simplify like LCM. 1 into beta cube is beta cube. 1 into alpha cube is alpha cube by alpha cube plus beta cube. Alpha cube into beta cube. Okay. Now still we have the denominator alpha cube plus beta cube. Here not there anything means by 1 we can write. So let us transpose to numerator this one. Then it will be beta cube plus alpha cube by alpha cube into beta cube into alpha cube plus beta cube by 1. When you take it to numerator, it will be 1 by alpha cube plus beta cube. Now observe, numerator and denominator both are same. Alpha cube plus beta cube or beta cube plus alpha cube both are same. So I can cancel and the remaining term is 1 by alpha cube into beta cube. I can write alpha into beta whole cube. Alpha into beta whole cube. What is alpha into beta value? Minus q. So minus q whole power 3, that is equal to 1 by minus q cube. And last step you should write minus 1 by q cube, because we should not leave negative to the denominator. So your answer is minus 1 by q power 3. Okay. Only simplification takes the process. I can directly cancel here only. To understand, I just expand everything like this. Yeah, please note it. Yeah, let us go to the next problem. Yeah, these are very, very important sum. X square minus cx plus d equals to 0. X square minus cx plus d equals to 0. And the second, x square minus ax plus b equals to 0. Clear until then? Two quadratic equations have one common root and second has equal roots. That means if you are taking the first equation having the roots alpha, beta, two different roots, and the second one has equal roots alpha and alpha. Both we should take alpha or both we should take beta, because one common root among the two equations, one of the common root is having, I am taking alpha is the common root. That's why in second equation also having alpha, and according to the statement second has equal roots. That means if you take alpha, both are alphas, or if you take beta as a common root, both are betas. Okay, na? Now from first equation, sum of roots alpha plus beta value minus b by a. So minus b value is minus c. A is nothing but x square coefficient. X square coefficient is 1. So minus of minus become plus c. And product of roots alpha into beta. What is that? Constant term by x square coefficient. Constant term is d and x square coefficient is 1. D by 1 means d. So this is from the first equation. Now let us check for second equation. Second equation, sum of roots. Both roots are equal. That means alpha plus alpha. Sum of roots means alpha, and second one also alpha. Both alpha plus alpha. Same formula, minus b by a, minus of b value also minus a. That means b is nothing but your x coefficient. Minus a by 1. Minus or minus plus a. and alpha into alpha. Product of roots c by a, that means constant term b by a. B by 1 means nothing but b. Okay, now let us find 2 times of b plus d. 2 times of b plus d, that is equal to b value means alpha into alpha, alpha square. Okay, b means here alpha into alpha, alpha square, plus d. In the place of d, what is given? Alpha into beta. Okay, clear? Yeah, 2 times of b plus d equals to, what is the alpha value? First of all, we need to find alpha value, right? Because to substitute in this alpha square and alpha beta, we have to find alpha value. Now I can find alpha value from here, because alpha plus alpha is nothing but 2 alpha. In the place of alpha plus alpha, you can write 2 alpha. 2 alpha value a, and alpha value is a by 2. Alpha value is a by 2. Now substitute a by 2 whole square, because alpha square, that one. Alpha into beta. Now from this alpha plus beta value c, then alpha value a by 2 you can substitute here. A by 2 plus beta equals to c. Beta is equal to c minus a by 2. In the place of beta, you should substitute this one. Alpha into beta. Okay, na? That means alpha value is a by 2 into beta value is, beta value is c minus a by 2. Clear? From these conditions, I found sum of roots, product of roots. Second one also. From sum of roots, I can find the value of alpha, that is a by 2. And that a by alpha value substituting in the first equation, because both are having common factor. So from this, I can find beta value c minus a by 2. Let us simplify this. That is equals to 2 into a value is a square. Or simply, without substituting here, we can do one more easy way, easy simplification. Let us see this, because both the terms containing alpha is there, no? Both the terms containing alpha. So I can take alpha as a common term, then for us simplification will be easy. Here too, I can take alpha as a common term, still alpha plus beta remains. That equals to 2 into alpha value is a by 2. And alpha plus beta value is c. It is very easy, right? Alpha plus beta value is c. No need this one also. So a, numerator and denominator cancel. A into c is equals to a. Done. Okay? Finished it. Please note it. Right. Let us go to the next problem. Yeah, alpha beta are the roots of the quadratic equation ax square plus bx plus c equals to 0. Then the equation whose roots are, see here, a into alpha plus b and a into beta plus b. Let me write alpha beta are roots. First this alpha beta multiply with a, then a alpha, a beta, then add both sides b, for both of them b, then it will be a alpha plus b, a beta plus b. Okay, na? That is only condition here. So actually, when we have the alpha plus k and beta plus k are roots, then the quadratic equation is, what is the quadratic equation? F of x minus k. That means that plus k we need to transpose that set. That means inverse operation of plus k minus k we have to take. In same way, what is the condition here? X, yeah, plus b transpose that set minus b. So x minus b. But here both sides a is multiplying. A is multiplying means k into alpha, k into beta are roots of the equation f of x by k. That means when k is multiplied, we are taking in the form of denominator x by k divided by k. Same way here, a is multiplied both sides. So our required quadratic equation is f of x minus b by a equals to 0, which are having the roots a alpha plus b and a beta plus b. Okay? Right. So what is the equation here? Ax square plus bx plus c equals to 0. So in the place of x, just substitute x minus b by a. That implies in the place of x square, x minus b by a whole square plus b into x minus b by a plus c equal to 0. Now can we cancel here a and a, both are, one is numerator and one is denominator. Can we cancel like this? No, because first we have to find the value of bracket. That means it indicates a square number. That means it is not a, it is a square. The square should be applicable for both numerator and denominator. Let us simplify. A into, I am writing separately, numerator square x minus b whole square and denominator a square. Okay? Plus b into x bx minus b into b square whole divided by a, like distributive property, and c equals to 0. Let us simplify. Numerator a and denominator a cancel. Still one more a is remains. And here numerator x minus b whole square. It is looking like a minus b whole square, right? What is the formula for a minus b whole square? Yes, very good. A square plus b square minus 2ab. Just apply here. X square plus b square minus 2xb. Okay. Denominator a plus bx minus b square divided by a. It is also having the denominator a plus c equal to 0. Now just multiply entire equation with a. That means multiply a with both sides. Now here numerator a, denominator a cancel. Second term also numerator a, denominator a cancel. Third term a into c becomes ac. So simply this equation will be x square plus b square minus 2xb. I can write 2 into bx. xb or bx both are same according to commutative property. Now this one plus bx minus b square plus ac equals to 0. 0 into a is 0. Now plus b square minus b square cancelled. X square term minus 2bx plus bx, both are like terms, both are bx terms. So bx we can subtract, here 2 times, here 1 time we can subtract. So minus bx plus ac equals to 0. This is our required answer. X square minus bx plus ac equals to 0. Option 1. X square minus bx plus ac equals to 0. Please note it, children. So just it is taken 5 steps, 1, 2, 3, 4, 5 steps. You should identify this one. It is also one of the transformation rule. It is also one of the transformation rule. Okay. Yeah, let us go to the next problem. Yeah, two equations have a common root than the value of a, and the common roots also we should find. Yeah, okay. So what are the equations here? X square plus 4ax plus 3 equal to 0, one of the equation. And second equation is 2x square plus 3ax minus 9 equals to 0. Have common root, it seems. So let us take the common root is alpha. Let the common root of both the equations is alpha. I am substituting here alpha square plus 4a alpha. Substitution means in the place of x only we should substitute. So x square alpha square, yeah, plus 3 equals to 0. Here also 2 alpha square plus 3a alpha minus 9 equals to 0. Okay, na? Right. Now the second equation I am writing here, 2 alpha square plus 3a alpha minus 9 equal to 0. Okay, na? Check. Now I am just comparing alpha square term, alpha term and constant term. That means alpha square term, alpha term and constant term. Alpha square term, that means except alpha term, alpha square terms remaining, like cross multiplication we should check. What is that? 4a into 9, only coefficients we should take. 4a into minus 9, okay na? Yeah, 4a into minus 9 minus 36a. 4 9s are 36, 36 into a, 36a minus 3 into 3a, 9a. So let me explain here. For example, the given quadratic equations are in the form of a1x square plus b1x plus c1 equal to 0, a2x square plus b2x plus c2 equals to 0. These are two different equations. For comparing x square term, x term and constant term, x square by b1 c2 minus b2 c1. Okay na? X by except, that means closing of x term, a1 c2 minus a2 c1. Middle minus we should take. Same way constant term. Last time we leave it a1 b2 minus a2 b1. Like this we should compare. Same order I am writing here. Okay na? Next, alpha term, that means middle terms. We are leaving this 1 into 3, 3 minus 2 into 3, 6. 3 minus 6. Okay na? Right. Next, 1 constant, this one. 1 into 3a, 3a minus 2 into 4a, 8a. Right. Simplify this. That implies alpha square by, both are negative terms, add with negative symbol, minus 45a, that is equal to alpha by 3 minus 6 minus 3. Okay, right? Yeah, sorry. 1 into minus 9, this is minus 9. Minus 9 minus 6. 1 second. Yeah. Minus 9 minus 6. So minus 15. That is equal to 1 by 3a minus 8a is minus 5a. Now equate both of them. These two. Alpha by minus 15 equal to 1 by minus 5. Both denominators containing minus symbol cancel. 15 is dividing transpose that side. Multiply. It is 15 by 5a. 5 times 15 3 times, that is equal to 3 by a. We got alpha value is 3 by a. That alpha value you need to substitute here. Okay na? Now compare these two. Alpha square by minus 45a equals to, what is that? 1 by minus 5a. Okay na? So substitute in that. Minus minus cancel, alpha square equals to 45a by 5a, a cancel, 5 table 9 times. Alpha square value is 9, alpha equal to plus or minus 3. Alpha equals to plus or minus 3. That alpha value, if you substitute here, you will get 3a value also. They are asking a value also, no? Now I am writing here. What is alpha is equal to 3 by a we got. So alpha value plus or minus 3. Plus or minus 3 equals to 3 by a. That means transpose this set a is equal to plus or minus 3 by 3. A value plus or minus 1. So alpha value is plus or minus 3, a value is plus or minus 1, our option is 1. Okay, na? Yeah, please check it, and it is running out of time. Yeah, that's it for today. Please note it. Thank you, one and all. Have a nice day. Bye bye.